In this video, we're talking about how to solve a system of linear equations. And in this particular problem, we've been given a system of three equations. We have x equals 2y, x plus y plus z is equal to 9, and x minus 3y minus 2z is equal to negative 8. So we have three equations and three variables. Keep in mind that you always need at least as many equations as you have variables in order to be able to solve the system. So, for example, if you had three variables and only two equations, you know right away you won't be able to solve for the solution. But in this case, we have three variables and three equations, so we should be able to solve for the values of x, y, and z that make all three of these equations true. In order to solve for that set of values, the set of values x, y, and z that make these three equations true, the first thing we want to do is try to isolate one of the variables by itself. And oftentimes, one of the ways that we're going to do that is by eliminating a variable. Now, notice that our first equation tells us that x is equal to 2y. This is a great place to start because we only have two variables involved in this equation, as opposed to the other two equations which both have three variables. What we want to do, since we know x is equal to 2y, is take 2y and substitute that in for x into these other two equations. So in other words, since we know x is equal to 2y, we're going to take 2y and we're going to plug it in here for x, and we're going to plug it in here for x, since these two things are equal. When we do that, plugging it into this first equation here, we're going to get 2y plus z is equal to 9. When we plug it into the last equation here, we'll get 2y minus 3y minus 2z is equal to negative 8. Now we have multiple y terms, so we want to go ahead and collect like terms. 2y plus y is going to be equal to 3y plus z equals 9. And then here we have 2y minus a 3y. 2 of them minus 3 of them gives us negative 1, so we'll have negative y minus 2z is equal to negative 8. Now what you can see is that we've simplified our system because now we have two equations in terms of two variables. So instead of three equations in terms of three variables, we have two equations in terms of two variables. So our system is simpler. And when you have two equations in terms of two variables, a great way to solve is to add the equations together or subtract them from one another in order to eliminate a variable. So in this case, what we can do is take this first equation and multiply the whole thing by 2. If we do that, we'll end up with a 2z. We'll also have 6y and 18 over here. But the point is we'll end up with a 2z. And if we have 2z, then we can add both of these equations together and we'll have 2z plus a negative 2z, or 2z minus 2z, which will give us 0. The z's will cancel and we'll be left with y's only. So that's a great way to approach this. Let's go ahead and do that. When we multiply this equation here by 2, we'll multiply by 2 like this. Now we have to distribute the 2 across each of these terms. So 2 times 3y gives us 6y. 2 times z gives us plus 2z. And 2 times 9 gives us 18. So we get 18. Now we have here negative y minus 2z equals negative 8. Now, like we said, we want to add these together. So we want to add. So let's go ahead and put an addition sign and then put brackets around this so we understand what we're doing. 6y plus a negative y is just like 6y minus 1y, or 5y. 2z plus a negative 2z is like 2z minus 2z, which is going to be 0. So those two will cancel. And then 18 plus a negative 8, or 18 minus 8, is 10. Now we just have one equation in terms of one variable, and of course we can solve this by dividing both sides by 5, and we get y is equal to 2. Whenever you find a value for one of the variables, I like to go ahead and put a big box around it like this so I don't lose track of it. I know that y is equal to 2. I now need to use this value to find values for x and z that correspond with y equals 2. So how am I going to do that? Well, I want to look for the easiest way to find the next variable, and in this case, that's to plug y equals 2 back into this equation for x. When I do that, I'm going to get x is equal to 2 times 2, because I plugged 2 in for y right here, and I'm going to get x equals 4 when I multiply that out. So there's my value of x, I have my value of y. Now I need to find a value for z, and the way I can do that is by plugging x and y into this equation. X plus y plus z is equal to 9. So I know x is equal to 4, so I'm going to plug it in here for x, so I'll get 4. Then I have plus y. I know y is equal to 2, so I want to say plus 2. Then I'm trying to solve for z. I need to leave that in there, so I'll get plus z is equal to 9. Now I just want to simplify. I'll get 4 plus 2 is equal to 6, so 6 plus z equals 9. Subtracting 6 from both sides, I get z is equal to 3. So now I have a value for z. The last thing I want to do is use these three values, double check myself using this last equation here. Remember, I found my value of y, then I used this equation here to find my value of x, then I used this equation here along with my values for x and y to find an equation for z. So I know that with the values x equals 4, y equals 2, and z equals 3, these first two equations are true. But I want to prove to myself that this is the right set of values by plugging all three of them into this last equation here. So when I do that, I have x equals 4, I'll plug that in for x, I'll get 4. I have minus 3y, so I want to say minus 3 times y equals 2, minus 2 times z, I know z is equal to 3, and I have equals negative 8. When I simplify this, I'll get 4 minus 3 times 2 is 6, minus 2 times 3 is 6, is equal to negative 8. Simplifying the left-hand side, 4 minus 6 is a negative 2. Negative 2 minus 6 is a negative 8, so I get negative 8 is equal to negative 8, and that checks out. That's exactly what I should get, is the same value on both sides. If I don't get the same value on both sides, then that means there's something wrong with my solution set. But because this checks out, I can say that the solution to this system of linear equations is this point here, x equals 4, y equals 2, z equals 3.